Hello guys, my name is Engineer Ali. I want to look at part 4 of measurement and unit, and let's take it one after the other. Let's start from 1978, number 10. It said to determine the weight of an object, you could use dash A, use beam balance, B, use a spring balance, C, find the force necessary to give it a certain acceleration, D, use any of this method. The best answer to that question, number one, say using beam balance. Beam balance, well, use beam balance. It means we are measuring mass, not weight. We use spring balance to measure weight. B said use a spring balance, yes. C says find the force necessary, no. D says use any of this method, no. Any of the method cannot be used. So take note of that. So the answer to that question is option B. Spring balance. You can look at the board and see all the analysis I've made. Don't forget, mass is a function of matter, while weight is a function of gravity. And spring balance is used to measure what? Weight, using the principle of moment. For mass, we use what they call beam balance or butcher balance, or we use lever balance and even chemical balance to measure mass. So using the principle of moment, while spring balance using Hooke's law principle. Also, weight is lower at the equator of the earth and higher at the pole of the earth. So if I have a rough sketch of the earth like this is the equator and this is the pole, this place. We understand that at the equator, the radius is high. As such, we said what? The weight will be low. Then at the pole, the weight will be high because the radius is low. Using the what? The formula, we know that weight is equal to what? Gmm over r squared. This is the gravitational force. Now, don't forget also that the weight on the earth is higher than weight at the moon. Reason being that the gravity on the earth is higher than gravity of the moon. So, in case we are not explaining how weight varies from one planet to another, let's use a case study of the moon and the earth. If a boy of 2 kilograms is taken from the earth to the moon, we observe that the earth, let's say 10 meters per second square is the gravity of the earth. We notice that this boy will have 20 Newton, a 2 kg boy, we have 20 Newton on the earth. But when taken to the moon, let's assume 1.67 meters per second square as the gravity of the moon. The boy will have 2.34 Newton on the moon. That is what? Very small compared to that on the earth. So you could imagine how a boy of 2 kilogram Newton or 2 kilogram boy mass could have 20 Newton on the earth and having 2.34 at the moon. So that is so small. So that means when we are moving from the earth to the moon, your weight is reducing. But when you are moving from the moon to the earth, your weight is actually increasing. But what about the mass of the boy? The mass of the boy of 2 kg will remain the same, will be constant, even when moving from one planet to another. That brought us to the summary of what we have written on the board. The mass is a quantity of matter containing a body, can add containing a body to it, contain in a body. While what? Weight is a function of gravity. Weight varies from one planet to another, mass is constant. Mass is measured used with a beam balance, butcher balance, lever balance, chemical balance, or using the principle of what? Moment, while weight is measured with what? Spring balance using the principle of what? Hooke's, and many more. Weight is a derived quantity while mass is a fundamental quantity. Let's go to number 2 quickly. It says one of the following readings represents measurement of length of a metal rod using vernier caliper. Now, you want to measure the length of a material. Don't forget all these things because it will occur again. Then I will not need to go back to this again. Now, what we want to do here is that we know we have what they call the meter rule or we have the rule, the meter rule, the vernier caliper, and what we call the micrometer screw gauge. Micrometer screw gauge. These are the four major instruments that we use to measure length. Now, the major thing we need to understand about these four is that know the maximum error. The maximum error of each of them. This one should be 1 centimeter, or what we call the 10 millimeter. This one has what? 0.1 centimeter, or what we call 1 mm. Then this one should be 0.01 centimeter, or what? 0.1 mm. Then this one is what? 0.001 cm, which is what? 0.01 mm. Now, then we have what they call the least possible error. Now, the least possible error for this is just maximum error divided by 2. So 1/2 times maximum what? Error will give us the least possible error, which is equal to what? 0.5 centimeter or 5 millimeter. This is what? 0.05 centimeter or 0.5 millimeter, as the case may be. This one is the same. With what? The least possible error and the maximum error are the same for what? For vernier caliper and micrometer screw gauge. So in our analysis, basically we be able to understand this. Now rule is used to measure long distance object like the length of a field. Sometimes we call it tape rule. The meter rule is used to measure laboratory equipment, maybe a short distance, the length of a thread used in performing a simple pendulum experiment. Then vernier caliper can measure both what? Internal and external diameter. External what? Diameter of a curved object. E.g., a curved object like what? A cylinder, a test tube, and all that. So the difference between them is that this one measure more accurately what this one could not measure. And again, this one only measure external what? Diameter. So that means vernier caliper has an advantage in this regard, that you can measure both what? Internal and external. But this one, micrometer screw can only measure only external diameter. Now let's look at it. And don't forget that when you are talking about the least possible error of an instrument, you are talking about what? The correct precision, which refers to what? To repeated measurement of a particular thing, in order to check one after the other whether they are close to this to the first measurement is close to the second measurement, indicating consistency of that particular instrument or tools or method used. So that is what we call precision. So that means you are going to make sure that whatever value you have must be that is measured should be close to the true value, the accepted value. That is what we call precisions. So that is just that. Now, another thing again I want us to look at is what? Let us go ahead to look at the question. He said what? One of the following readings represent the measurement of length of a metal rod using vernier caliper, taking the reading accuracy into consideration. Now, the most likely one is what? 5.16 is what? Option A, centimeter, which is that one should be what? Vernier caliper. Take note of that one. B says what? 5.165. That one is micrometer screw gauge, 3 decimal place. Whenever you see 3 decimal place in centimeter, that is micrometer screw gauge. Then 2 decimal place in centimeter is what? Vernier caliper. Then this one can be 1 decimal place in centimeter or 2 decimal place with the second decimal place having a multiple of 5. For example, 1.15. 2.25, 3.75. The second one can be what? This one can take a meter rule because the second decimal place is ending with 5. So please take note of that. But majorly one decimal place. Then this one whole number. Now let's go ahead. Number option B says 5.16 centimeter. No. C says 5.0 centimeter. That one is meter rule. D says 5.160. That is micrometer square. So the option A is the answer. 5.16. That is 1982, number 3. Number 3 question now. It says, which of the following statement is true about stream balance and chemical balance? Both are Roman figure 1. Both are used to measure the mass of an object. No. Both of them cannot be used to. Either of them may be used to measure the weight of an object. No. Either of them means that any of these or this can be used. No. That one can what? Either of them. That means any of them. Either is opposite of neither. So number 3, that means that one is wrong. Number 3, Roman figure 3 said, well, the spring balance work on the principle of Hooke's law. Yes. Why the chemical balance works on the principle of moment. Yes. Correct. The Roman figure 4, a change in gravity changes the reading of the spring balance. Yes. But not the chemical balance. Yes. Because change in gravity will change the spring balance. I told you, if you check the last analysis I did, you see there. So the answer is what? A, 1 and 4. B, 2 and 3. C, 2 and 4. D, 1, 2 and 3. So I will go with what? 3 and 4. Option C say 3 and 4. So I will go with option C, 3 and 4. So please take note of that. Number 4 is which of the following represent the correct precision? I've explained correct precision. It's talking about what? It refers to how close repeated measurements are to one another, indicating the consistency of the measurement or measuring tools and method. Okay, so that is already settled. Let's read the question again. So which of the following represent the correct precision if the length of a piece of wire is measured with a meter rule? A says 35 millimeter. 35 millimeter is still the same thing as what? 3.5 centimeter. Don't forget. B said what? 35.0 millimeter. That is equivalent to 3.5 centimeter. 3.50 centimeter. C says 35.00 millimeter. This one is what? 3.500 centimeter. Then the last one says 35.01 millimeter. That is indicating what? 3.501 centimeter. If you actually look at it very well, I break it down into centimeters so that for clarity. This one is micrometer screw gauge. This one is what? Micrometer screw gauge. This one can be meter rule or vernier caliper, 2 of them. But this one is meter rule. So the one that actually carried the meter rule is 35 millimeter. So I will go with what? Option what? A, which is 35 millimeter. So that one is specifically for meter rule. I told you this one can be 0 is a multiple of 5 because 5 plus 5 is 10, which 0 indicating 10 here. So this one can also be, we can use meter rule to measure it. I use vernier caliper, which is vernier caliper because that's what 2 decimal place in centimeter. So in that case, I will go with A. A is very correct. Number 5, which of these following is, what is the least possible error in using rule graduated in centimeter? Rule graduated in centimeter is what? Is 0.5 centimeter. As I've explained before, A, 0.1 centimeter, B, 0.5 centimeter, C, 1.0 centimeter, D, 2.0 centimeter. So the answer to that question is B, 0.5 centimeter. What is the reading of the vernier caliper? Number 6. What is the reading of the vernier caliper shown below? This is the vernier caliper. Now, what to see this question? It says what? The vernier caliper is drawn on the board like this. We need the main scale. The main scale is what? The up one. The up in centimeter. The vernier scale is it down. This is the vernier scale. Now, in this case now, the main scale, what is the value here? This 1, 1.1, 1.2, 1.3. So this is 1.30 cm. What about the vernier scale reading? The vernier scale. What is the value of vernier scale? Now we'll now look at where this is a 0 mark of the vernier scale. So we count the numbers. Here we stop counting where the main scale and the vernier scale meet. I've seen one there. So that means 1, 2, 3, 4, 5, 6, 7, 8, 9. So the main scale and the vernier scale meet at this vernier scale and this main scale. They coincide at the point 0.09. Each of this one is 0.01. 0.01. So it meets at 0.09 cm. So what I want to do is to add them together. What I would have now, this 9 to get the readings. The readings now be 1.39 centimeter. So we have option A in there, 1.79 centimeter, B 1.73 centimeter, D 1.39 centimeter, C D 1.34 centimeter, A 1.79, B 1.73, C 1.39, D 1.34. That is 1994 number 1. The answer to that question is what? Option C is the answer. Let's go to number 7. He said the inner diameter of a small test tube can be measured accurately using dash. A, micrometer screw gauge. B, pair of divider. C, meter rule. D, pair of vernier caliper. Now, the best answer to measure anything I told you, to measure the inner diameter, whether it's small or big test tube, the best instrument to use is pair of what? Vernier caliper, which is option D. I told you, go and check the analysis I make so I will not be making. You can measure both internal and external. Don't forget that anytime you want to measure the inner diameter of a cup shape, you use what? A vernier caliper without option. But anytime you want to measure a diameter, external diameter of a test tube, or maybe a rod or anything, you use vernier caliper. But anytime you want to measure external diameter of a small object, thin object, tiny object, they qualify them with small, tiny, anything like that. You use what? Micrometer screw gauge. For example, the diameter of a thin rod, we use micrometer screw gauge. But if you want to measure the external diameter of a rod, we use vernier caliper accurately. If you want to measure the thickness of a piece of paper, use micrometer screw gauge. But if you want to measure the what? The ball, the diameter of a ball bearing, use what? Of a ball, we use vernier caliper. But if you want to measure the diameter of a small ball, when they use that word small to qualify the main word now, or the name of the thing, we call it what? Micrometer screw gauge. So take note of that. Why this small is very useless in this question. The inner diameter of a small test tube can be measured accurately using that. Why it's very useless? Because inner diameter of a cup shape can only be measured with vernier caliper. So we go with option G. Number 8, which is the last question for this part, is that we want to solve this question. I said what? The length. Okay, this is not number 8. I think that should be number 9. Sorry. We'll continue this question in the next section. Number 9 says what? Let's see. The length of a piece of glass plug was measured by means of vernier caliper as shown below. Okay, it's number 8. Sorry. Number 8. Sorry for that. It's as shown below. The length of the block is dash. So they measure with vernier caliper and they draw the diagram below. Now that is 2003 question 4. Jam question. So this one now, how do we do it? How do we measure it? This 1, 1.1, 1.2, 1.3, 1.4, 1.5, 1.6. You stop before the the 0 mark. That is where the main scale will stop. So the main scale is 1.60 centimeter. You stop before this place. Just by using 1 1.1, 1.2, 1.3. That's why it's 1.3. So master it and understand how we read it. Then you now check where the main scale and the vernier scale, where they meet. I mean, where they kiss. So look for that, where they meet, like meeting like this. So that is it. Now, in this case, what do? We look at, this is what? First one, they did not meet up and down. Second, third, fourth. Okay, look at the fourth one now. Very good. They both were side. They both meet at that point. The fourth one on the vernier scale. So, and each of this one is 0.201, 0.02, 0.03, 0.04. So, this is 0.04 cm. So, final answer will now be equal to what? The reading. The readings is a vernier scale, a vernier scale reading. So the reading now, total reading of the scale is what? 1 point, you add it together, plus 64 centimeter. So that will be your final answer. Thank you very much for watching this video. If you know you enjoyed, please click the like button and subscribe to my channel. God bless you.